Microphone just happened.
I'm Fatemeh Alidoost, a PhD student in photogrammetry at the University of Tehran. My supervisor is Dr. Arafi. The topic of my presentation is application of deep learning for emergency response and disaster management. As you know, many tragic and hazardous natural disasters reach different locations of the world each year. Some reasons of increasing the incidence of natural and man-made disaster could be global climate changes, unplanned urbanization, and population growth, and so on. According to some international references, the total economic and impact of global disaster in the duration of 10 years is about 1.2 of the deaths, 2.9 of building billion affected area, and 1.7 trillion damages. So emergency management strategies are being put under the microscope. So what is the solution? One of the solutions could be develop a rapid emergency response system, since effective countermeasure for disaster situation will be established only if more accurate and real-time spatial information for emergency. So developing of such system is important to efficiently handle this situation and decreasing the negative impact. This emergency response need to be not only intelligent but also more customized to the individual sites to manage the emergency better. If we want to review some previous studies quickly, we can conclude that some of existence of or developed emergency response are not capable to real-time processing, and so they need a ground station to process the data and calculate the damage of the disaster. Also, some developed systems are limited to indoors application or need to be close enough to disaster area to monitor or measure the disaster. On the other hand, the supervised learning approaches don't generalize enough to transfer to other different remote sensing data or different locations. Another problem is that the visual interpretation by an expert is tedious and may lead to wrong result. Another problem about previous studies is that some of these methods need both pre-event and post-event data, which are not available in many cases. So the solution is having an emergency response system that the system is contingent on real-time access to geospatial information over affected area. So the combination of computer vision approaches, aerial images, accurate by UAV-based, could be a solution to have a low-cost and flexible system that could be used for rapid mapping for emergency response. As you know, the UAVs are shown better result in larger scale mapping because they are robust, fast, autonomous, and can access hard to reach areas. So we can conclude that UAV platform could be used for collection of geospatial data for rapid response mapping application. But there is a disadvantage because the UAV and the current UAV are not capable to real-time data processing and product delivery. So, if we want to have a real-time or near real-time response mapping system based on the combination of UAVs and intelligent processing algorithms, we can use deep learning techniques. And this structure can be called deep I. Deep I is composed of the UAV and deep learning algorithms on board that this can be provide for us the vital information of a disaster, such as the type of the disaster, the percentages of destruction, and the precise location of damaged area. That this information could be transferred to a ground station to trigger an alarm-like system. But what is the deep learning? Deep learning is a field of machine learning and artificial neural network based on hierarchical learning representation of data using a deep structure composed of multiple hidden layers with nonlinear or linear transformation. There are different applications for deep learning, such as object detection, semantic labeling, image classification, again semantic labeling, speech recognition, face recognition, and so on. In comparison with shadow architecture that we have in traditional classification algorithms such as SVM, PCA, nearest Cummings classification, we have deep architecture. Deep architecture is based on purely on brain. In brain, audio or visual cortexes has multiple stages that we can learn different objects in the nature based on hierarchical framework. So deep learning is based on the brain and can learn feature hierarchically. The most important of the deep learning is that with deep learning we can model some complex functions that the shadow structure cannot model them. And with not a limited, with not a lot of many elements that you want to need to model. And also the CNN feature are highly transferable. It means that you can use the CNN feature for different applications and different locations, but you can use two different techniques for use these characteristics, such as feature transferring techniques. There are many different deep learning algorithms, such as deep neural network, deep deep network, convolutional neural network, and so on, that we want to focus on convolutional neural network. Convolutional neural network was inspired by biological process, and the typical CNN structure has three sections: an input layer that could be an image matrix, hidden layers such as convolutional layers, compelling or filling layers, and fully connected layers. And finally, output layers that could be a fixed length vector of CNN features. The example of simplest and complex structure of CNN are lineage and resonance. The CNN has a series of stages, and in each stages, feature maps are onboard with different filters that they are subject to training, and feature maps are passed through some nonlinear activation function, and then sampling layers are responsible to reduce the resolution of the feature maps. So when the input image pass through this layer, the spatial resolution of image is decreased, but they encode the high-level features for you. And finally, we have a fully connected layer that the result of your CNN features. The training of CNN composed of two methods. The training from scratch is random values of weight. In this method, you should use a large training data set because you use random values of weight to train several million parameters of CNN. So you need a large data set and the computer system and the powerful computer system as well as time. But there is another training method that's called fine-tuning of a pre-trained model. In this method, you don't need a large training data set. You use a small data set and you can use the base of a pre-trained model as the initial values of your CNN models and use a backpropagation algorithm to improve this way for your application. Deep learning application in disaster management. In recent years, some people use the power of CNN for different applications such as disaster detection. For example, Russia used CNN to detect damaged building and generate a library for training manually and a pre-trained model called VGGNet. In this method, we extract a feature from raw image, feature from color mask image, and feature from binary image and combine them in a CNN framework to improve the result. This is the category classification of different damage of building from 0% to 100% of damage. This is the result of this method. This is the raw image. This is a mask image. This is a, I don't know if it's clear or not. This is the ground truth number of percentage of damage building, and this is the final result. For example, if the building doesn't any damage, the result is 0%. But if the damage is high, building is completely damaged, the result of the CNN is 97%. In another board, some people combine the CNN feature and 3D point cloud features based on a multiple kernel learning method. And also they create the training data set manually, but they use the powerful system, and the average classification accuracy of this method is 94%. And this is a sample of the training data set and the flowchart of this algorithm that use CNN feature and different features extracted from point cloud combined to improve the result of the CNN. This is the result of this paper that they can detect the damage in the building area. The CNN also could be used for flood and landslide assessment. For example, in this flowchart, you can see the process that the CNN used for image classification to detect the pixels that are affected by landslide or flood. Another application is fire detection. You can use the CNN for detected fire in the image or a smoke in the image and separate them from other. For example, in this paper, use CNN and max cooling feature to detect the area affected by fire in foresty area. And also we have another example that we use CNN for fire detection. This is the ground truths that they are created for training process, and this is the result and comparison result with the SPN, CNN, and improved CNN based on the proposed algorithm. Another application of deep learning could be building detection. For building detection, some people use the CNN structure to detect the building in satellite or aerial images. For example, this study used CNN to detect building in coarse resolution in Google Earth satellite images, and you can see we have also some wrong result in some areas. Or in another studies, people use CNN with the combination of the sign system function to detect the building in larger scale areas. This is the result of their work. And finally, our proposed method for building detection using single aerial images with a hierarchical framework that we use a pre-trained CNN model and a small library. We generate the training data set offline, so we could ignore the time of generating the library for training process in real-time processing, and our average accuracy of building detection is about 99%. As you can see in this slide, we can use a pre-trained model and pre-trained model for fine-tuning our model. And when your model is prepared, you can fit some candidates region to CNN to detect the building from other objects such as tree or road in urban areas. This is the result of candidate region extraction that we use selective search algorithm to extract this candidate, and all of these candidates fed into our CNN to detect the area of building. So the most challenges in deep learning is creating the training data set. As we know, there is a few available data set for with annotation for remote sensing application, especially building detection or disaster detection. So we have two options. We should produce a large data set that we need a powerful system, or another better option is that use a small data set, but using some techniques such as transfer feature or fine-tuning feature for training our CNN and have good results. In order to real-time processing for rapid mapping, need for a low-cost UAV-based emergency response system. So the combination of deep learning and UAV to collect near or real-time data for rapid response application could be a solution, especially in hard-to-access and hazardous area. And this is called the deep eye structure. Thank you.
Thank you for your very instructive talk, which gave me like an introduction, an overview over existing approaches and the work you are going to do and to continue. Thank you very much. I'd like to start with a question. I think Sashi used machine learning. Is machine learning something different than deep learning?
Deep learning are algorithms like random forest, and deep learning is network. It's neural network.
Okay.
It's different.
Different. Okay. Thanks. Okay. Sashi and then
Actually, I have also a few questions. First of all, thank you for the presentation. Very important. It's for me, I enjoy it. I have two questions. One is regarding the inputs, and the other is related to the training. On the input, I would like to know, can you put a set of inputs with data of different, let's say if you look at the satellite, satellite data of different sources. Is it possible to have a large set of inputs with different, let's say, resolution? That is regarding the input. And also, with the training, you mentioned that you have, for training, you have a method that you need a large data set, and also you mentioned you have a method which need a small number. Could you elaborate on what is large and what is small? To give some idea of the number of actually training data sets. Thank you.
About your first question is about input. You can use different input, but as images. I mean that you can have an image with different bands, with different channels, and in each channel you can put your preferred satellite images and try to see it.
You have a limitation on the number of, let's say, channels?
No, because we have some techniques for image classification of hyperspectral image. They are composed of many channels, and CNN can classify this image. There is no limit. The limit is sometimes in time or processing time or volume of processing. And regarding second question about the small or large, small I mean is little than 100,000 units, small, but the large is the million number of images. Yeah.
So you have different standards.
Yeah. Because we have over 100 million parameters in CNN models that we should learn in a iterative process. So for
But how do you provide 100,000 samples?
some people use Google or some similar website, for example, Flickr for image, Google, or there is some automatic extracting images from big image, and you can generate this image.
So in fact, that is one of the limitations.
The limitation is just in hardware, not in a story.
Providing is also.
Could you explain, go to what you did in your work, and you used also pre-trained model?
Yeah.
Yeah.
Yeah. For example,
what did you use as the library, the main library? Which library you have to use?
Which pre-trained model?
My model is BPGNet.
So the library, which library you use, and then you have to tune with your parameters.
Yeah.
Okay. What library was ImageNet? What was the?
No, BGG.
It was BGG library. And which sort of image has been?
It's a computer vision.
It's a computer vision. I mean, the main, it was already, for example, one library, another library has been created with a computer vision images, door, window, something like that. And it was already indexed and biased and weight had been measured. And she had just tuned his model using some small number of training data, for example, in this case building, non-building, to tune pre-trained model and then to generate the new weight and balance. This is
Just to understand, if the target is building,
yeah.
so you need to provide 100,000 of building as an input to the smart cell.
So also maybe there's two aspects which you already addressed. The one is the resolution. Is you can generate your own. You just reduce this image, of course not with a satellite image because then the building is gone, but if you take a high resolution image, you generate a sequence of resolutions and you take this, and then you get the scaling variants and you take the sequence of rotations and then you get rotation invariant, and this is all automatically generated training, and I think you did the same, right?
Yeah, this technique is data augmentation. Data augmentation is that you can set image, a small image, and automatically you can increase it with rotating, add noising, or another technique to increase your data.
Basic number of, different kind of building will be selected, and then using special algorithm for data augmentation. In this data augmentation function, this building will be automatically rotated in different rotation angles, scale in different scale angle, and scale factor, and you adding noise and something like that, and therefore the library will be increased.
That helps. Thank you.
Just to actually on the training samples itself. So, these training sets which are available like DGT or AlexNet, they consist of these photographs. Right? Photographs. My confusion always has been that when we deal with satellite aerial images, how do we? So you add the building samples from the aerial images to those training sets. Is it what we need to do?
To add what?
The training sets which are available in globally, they are all computer vision.
Yeah.
But we are classifying aerial images. This is totally different from what we see from this perspective, right?
Yeah.
So I assume that we have to add samples of buildings which is seen on an aerial perspective. Am I right?
Not really. No, sorry.
For training, but he means how the training, the tuning has been done.
For the aerial pictures.
Yeah,
aerial or
because the
satellite.
data, if computer vision, your data is area. You select some image from the building and something like that, and with this, the computer vision library.
Because it is the power of this learning, extract some features, not the shape, or it's robust to sensor, robust to techniques of accurate image deep learning. Deep learning extract feature in different layers, for example, corner, curve, and this feature is same as computer vision and aerial image. But to have a better result, you need a small data set just for fine-tuning this parameter, not the whole of this parameter, not at the base.
So you add that into the training set.
Yeah, this is a sample of my library for free, for road and for building, but the number is 2,400. Yeah, just this.
Small number of chunks.
Yeah.
And it would be also good to have this global training set for the aerial images representing different buildings, different agriculture. Is there any data set available
For building?
Yeah, for buildings from an aerial perspective.
Yeah, recently the media company released a CNN model that's name is DigitNet or SpaceNet, I think. I have another presentation if you want, I can see. This is a CNN model that they are trained based on aerial images. Digital glove and virtual images are used for training these models. Yeah.
One last question. Did you use Cafe or TensorFlow? Did you try TensorFlow?
MathHubNet I use.
Which was
MathHubNet. It's a MATLAB based conventional.
The window,
Yeah.
the window, the copy is line.
This is connected to a simple question. Is a right screenshot. This green rectangle is something like a sample site or training site? No, it doesn't. Or doesn't this doesn't exist? Or how does computer learn what is damaged and what is not damaged? We have to teach him. This is a damaged building. This is okay.
Yeah, you can generate a similar library for damage and
I got it. Okay.
yeah.
Okay. Charles, if you are finished, Charles, you had a question?
Yeah, I had a question, but not necessary to Fatemeh, to all of us. Based on that, deep learning and disaster detection, I was just thinking if there is any model or any mechanism that can detect the earthquake before it occurs to be part of the early warning system.
So the question is if there are any method to detect like a early warning system before an earthquake happens.
Yeah.
So then we can avoid this.
So it's be completely different.
God only God.
For earthquake,
I'm not convinced.
I know that's the reason for floods and other things, but now you can see the major disaster is on earthquakes. So it's not in the sense that can detect this and tell us that tomorrow, maybe the day after tomorrow, it is earthquake.
There are models.
So,
There are models, of course. Yeah.
Lots of people doing these things, but these are all experimental levels.
Right.
There are things going on.
I have
Some
heard.
minutes ago, they can say some Japanese and Taiwanese people are putting the very high pollution APKs in the ground and detecting the easily and correlating with the big data like natural other features and trying to get a conclusion. But still, these are experimental level, but not useful for the practical field. So we have to wait for another 10, 12 years maybe.
But there are stories, at least stories about animals which feel a tsunami coming or an earthquake coming. But I don't know if there is any
Correlation.
scientific research about this. But I have read this several times.
Yeah.
Therefore, if there might be some sensors and which could be used and all this sensor data could be fed into such a system and the system could somehow analyze it permanently.
Okay, I can ask a little more, one more question. As your last point was to use it for emergency situation to process UAV data, right? Do you think it's practical in terms, because deep learning, in my understanding, is very computationally intensive. So,
Communication, what?
computationally intensive.
For
Deep learning.
which aspect? For testing or for training? Because the training is done offline. You don't need the time.
So once the model is ready, it is it's easy.
Yeah.
Okay.
I mean, the part which is computational is so expensive in offline. I mean, you do it just once. You know, the generating the library is just once. I mean, I was just when I was last summer I was in Germany. I had a visit in technical university in computer vision lab. They use deep learning for real-time depth extraction using a single image. You know, first they did one using the Kinect, but Kinect at the same time that captured the image also decode the depth. That means for each individual patch you have RGB plus depth, and this has been used to generate to generate the training library, and this has been used to do that process, which is computation is so much expensive at once. And as soon as the library has been generated, the model has been done and made and biased as the output has been generated. This has been used for real time. I mean, the input was like that. I mean, since you generate, with the keynote, you measure RGB and depth. Okay, they said, okay, if the image like this is the RGB, the depth is that, because you measure at the same time. In most cases, in some cases, like the work that Fatemeh is doing, the training is like that. If you have this hash, there is a label called the filter group or in the graph. But in this case, there is no label. We have RGB, and there is no class until you have depth. You have, if you go here, you have RGB, you have depth. RGB depth, and you train the model like that. If you train the model like that, you just need to connect another camera, and since while the camera is moving, real time you could extract. And this is what I saw with this was really impressive. With this speed, you do one in the library, and you could take, for example, computer, take it to another room, and since you are moving the camera somewhere, automatically showing the depth. Of course, the quality is not as much as SSM or something like that. And the quality also depends on the quality, but the depth was really, really good.
Maybe one very short question. There is now quite a number of pre-trained networks, and some of them are maybe to see what kind of dot it is, or in the flower area they have great trained networks. Do you have any idea how we could, if you look for our houses, we know, okay, straight edges, if you do convolutions, this is probably something like edge filtering, so whenever there is straight edges, the library might be good to is trained for straight edges. Do you have any idea whether there is tools or advices available which kind of networks could be used, or well suited for this? Because if you take a flower trained network, it will not help you very much for the buildings. It may help you for the trees, yeah, but not for the buildings. Is there any tool available, or it's just if people use it for this purpose, we follow them and say, okay, then it's probably the best one to look for these applications also?
So far, I didn't see this tool or any software, but in different paper, I see that people try, they are with different network and computer, or this network is good. They are try and test. But there is a general rule that if you want natural image classification, use the network that train based on natural, not artificial. But generally,
Fatemeh Alidoost is live, so live, very unfortunately, very